Okay, the last problem that we talked about last Wednesday was this problem. Let's just review the pattern that we applied to solve this problem recursively. Given a string, let's say the string simply contains A, B, C, D, E, F, G, H, this many characters. What we want to do is, let's say this is the input. We want to return as the output the reverse of the string. So we mentioned there are two possible ways to solve this problem over here. And they're working a very symmetric way. I'll mention both intuitively. And then I'll show you the code for the very first one. And the second one is left as an exercise for you. Okay? So now, let's say this is the input. How do we generate the output recursively? Okay? Solution number one. Basically, what I would do is, first of all, let me use color to highlight. I'm going to take just the first character. Okay? Just the first one. And then I'm going to put the first character somehow at the end for the output. You can think about this is the input, and this is the output eventually. I'm still trying to see what should be the shape of the output. Okay, so now I have the first character, and I simply put it at the end for the output. And then what I will do is I'm going to reduce the original problem, which is going to contain A, but now I'm going to get rid of it, which means what I will get is what you will see over here in pink. So this is a new problem that I would like to solve recursively. Okay? So what I would do is I will simply try to see what is the reverse of this particular problem over here. Okay? That's what I would see. It's a strictly smaller problem compared with the original one because I have gotten rid of the first character. And then I would see what's really the reverse of, let's say, B, C, D, E, F, G, and H. I'll see what is that. Usually, when you're making a recursive call, you can simply assume it is just going to work magically. Okay? So all you got to worry about is the base cases, which we'll see in the code. Okay? So what will be the reverse of that? We'll simply get H, G, F, E, D, C, and B. So this is basically the solution to the subproblem that we talked about, right? And then you concatenate both of them together, and you get the reverse. Okay, that's the solution number one. And I will show you the Java code in just a moment. You will see that the idea I just talked about corresponds to exactly how the code is going to look like. You just have to know how to get a substring and how to get a first character using the string methods. Okay, now let's say for the same input, how we can still solve that recursively but in a symmetric way. So what I would suggest is, let me just repeat the input, repeat it. Let's say the input is, again, still A, B, C, D, E, F, and G, H. Still the same input. So now, rather than choosing the very first character over here to really solve first, what I would do is I'm going to choose the last character. Let's say I choose H here instead. And now, rather than putting that at the end of the output string, what I would do is I'll put it in the very beginning. So I would say over here, so this is the output over here. And then the first character, I'm going to put it in the very beginning. Okay? Once I got rid of this particular last character over here, so what I will get, again, let me put it in blue. Okay? Let's say this blue here. Okay, the blue one over here is, again, a strictly smaller problem, right? You can see the size is strictly less than the original problem. In this case, what I will ask would be, instead, what would be the reverse of, let's say, the subproblem over here? It will be A, B, C, D, E, F, G. Right? What's going to be the reverse? Again, since we are making a recursive call, you can simply assume eventually it's going to return the correct result. Okay? So what we'll do is we're going to see what the result is. The reverse of that is going to be G, F, E, D, C, B, and A. Okay? So that's going to be, and then we are concatenating the two strings together. That's how we get a final solution. So basically, for both solutions here, we are trying to apply recursion, but the subproblem that we are coming up with is different. Okay? For the very first solution, for the first solution there, this is the subproblem, which is to get rid of the first character. In the second solution there, this is the subproblem that we're solving, which is by getting the last character in the string. Any questions conceptually before I show you the code? Yes. The question is whether there will be any advantage for choosing either one. I would say no, definitely not. Okay? So if you want to talk about running time, which we'll touch maybe a little bit next time, but I would say in terms of running time, choosing strategy number 1 or choosing strategy number 2, it would just be the same. It's just really about the order of choosing either first or last character. And also either combine the first part or combine the second part recursively, right? So there's really no advantage about having which one, okay? It's really a matter of preference, okay? Now, let's have a quick look of the code, okay? If you look at the code over here, again, for every recursion, you have to make sure, first of all, you have to get base cases. Okay, let's check if you've got base cases. Over here, you will see that reverse of, which is a method we are defining, and then it's going to take a string, okay? String, we can simply say, if the string is simply empty, we know that reverse is simply itself, okay? If the length of the string is simply just 1, that's also a base case, and we simply return the string itself. So these are the two cases, base cases. You have no constraint on how many base cases you should have. I would say typically it should not be more than 2 or 3, typically, okay? So now we got 2 base cases, that's good. So now, criteria number 2, you want to make sure every time you're trying to make a recursive call, you must make the call on a strictly smaller problem, which means now the original problem I'm trying to solve is S, right? So now in this case, conceptually, rather than passing S entirely for the recursive call, we only pass the substring by getting rid of the first character, right? That's how we made the recursive call. That's what you will see. For example, you can see over here, we have a string simply called a tail. So you can just go back to the first solution here. I'm calling this part over here the tail of the string. Okay, that's what I'm doing here. So I simply say, now I'm going to get a substring starting from 1 until s.length. So you can review the API to see how to apply these methods. And then I'm going to say, what's the reverse of the tail? Okay, what's the reverse of the tail? If I only give the tail, it's going to be B, C, D, E, F, G, H. It's not exactly the answer just yet. So what I would do is I'm going to make a recursive call on that particular strictly smaller subproblem. So what I would do is I'm going to make a recursive call. Okay, and then I'm calling the tail. So now, how do we check to see the criteria number 2 is actually satisfied? Now, if you compare tail over here, okay, tail over here, and S. First of all, they're both strings. And we know that tail is strictly smaller than S, right? So that's what we know about. Let me just write it down. Okay, over here you can say tail dot length is strictly smaller than s.length. So this is really critical to identify. Every time you want to do a subproblem, make sure the subproblem is strictly smaller. It applies to all the recursive methods you have to define. And then we simply get a head of the string. You simply go character add position 0. That's how we get A over here, right? Once you get it, you will simply say, what's the you simply return by concatenating head, simply put it to the end, right? That's how we do it. Put it to the end. Okay. Guys, any question about this before I do one example with you? Are we okay with this?
So we're basically just making every letter in the string a character and
yeah, you can.
one by one.
Yeah, exactly. You're thinking about the array. The string is an array of characters. Yeah, just do one character at a time. Yes. Let's have one example altogether. How about that? Okay. Let's choose a small string just to get an idea. Let's say I simply call this reverse just to be a little bit easier for me to write. How do we calculate the reverse? Reverse of, let's say, simply A, B, C. Okay, just that. Okay? Eventually, what we should get is we should get CBA. That's what we should get eventually. But let's see exactly how this can be run. Now, for the first run, okay, again, if you want to practice your tracing ability, you may want to trace also by a stack, like how we did for Fibonacci number and also for factorial. But for the purpose of the rest of the lecture, I'll just use like a tree, okay, to show you. That would be easier, so we don't lose track that easily. Okay? So now let's say for the very first one, we're going to get a string. S is simply just A, B, C. Okay, we know that S is not empty, so we don't really reach here, right? And also, else if s.length, in this case, simply 3. So that's also not good. Okay? So what we will do now is we're going to first of all get a tail. What's the tail in this case? The tail would simply just be B and C, right? That would be the tail. And then we're going to make some recursive call. What we will do is we're going to make a recursive call to say reverse, and then reverse of the tail. In this case will be B and C. over here. And then we're going to get the head for the current string. What's the head? A. Okay? And then we simply get A over here, and then we say concatenate the two results together. So we say concatenates, right? So the original problem, which is to get a reverse of ABC, it boils down into two parts. One is the first character A, and also the reverse of the rest of the string, BC, right? So this part over here is not really recursive, so we don't have to worry about it just yet. We have to complete this one over here before we can reach any further, okay? Let's see how we can convert this into some base cases eventually. Again, let's use green. So what we'll do is, so now that means, let's say we got B and C over here. So B and C, okay? That's a new string we are talking about. So now we know that the length of the string is 2, right? So that means we are not going to reach the 2 base cases. That's straightforward, right? How do we do the same recursive case again? What's going to be the tail in this case? C, right? Because we know that whatever that's left besides the first character, right? So now we know that for the tail, it would just be C. And also for the reverse of, we're going to get a reverse of C. So this part will boil down into 2 parts, okay? And also the head will just be B. So that means it's going to be B plus the reverse of C. Okay, so far so good. And now we have to make sure we complete this guy here before we can do the rest. So now how do we do this guy here? Well, let's go and try that. Let's say, let me use orange, okay? Let's say we do C over here. Now, the string we talk about is C, right? Are we reaching a base case? Yes, we are, the second one, right? And it simply just return C itself. So that means this part here simply going to return just C. And then we go back to here, that'll be B plus C. That'll give us BC. And then we return again A plus BC. That's going to give us ABC. Okay? So eventually what we will get, the reverse of ABC will just be, oh, am I doing the wrong thing? Okay. Yes, thank you. That's good. So what have I done wrong in the tree? I put the order wrong, right? Okay, good. Sorry about that. Let me fix that. Okay. The way we do recursion is really the same, but all I have to make sure is, let me just do it again to clarify. Okay, but okay, what I would do is, let me just get rid of that part over here. Okay, let's do it again. Okay, and let me try to see if I can just shift this guy here to here. Oops. Let me do it again. Okay, that will do. Okay, let's start with the pink. The pink will simply say plus the head, in which case it would just be A. Over here, for the green one, it would be plus the head, reverse of C, plus the head, which would be just B. Okay, and then we know that for this one here, it would just be reverse of C would just be C, right? So eventually what we'll get is C plus B would be CB, right? And then over here, when we say whatever this is, that will be CB. And CB plus A will give us CBA, okay? Yeah, that's the correct version. I just did something wrong when I was trying to trace. Yeah, it should be corresponding to exactly this order over here. Okay, just make sure when you did the trace yourself, it's right. Any questions about this? Are we okay with this? Okay, hopefully you're rather comfortable with this, and we can go on. Okay, if no question, I'll assume you're comfortable with this. So now, what's really interesting about this problem here is we are really dealing with an array, really. It's basically an array of characters that we are trying to call the recursion on. But let's now talk even more general. What if you have an array as the input rather than just a string? Okay, that's something I would like you to focus on today, at least for the first half. Okay, okay, let's see this. Oh, before I do that, let me see this. Before I do the array, let me do one more. Okay, so that's the reverse of. Let's think about how we can do one more problem here for the string, and then I'll go to array. So a new problem here, we want to calculate the number of occurrences. Okay, basically, give you some example here. Let's say this. If I got occurrences of as a method, it would take 2 inputs. Okay. The first input would just be a string, like an array of characters. And the second input would just be a single character. I want to calculate how many times the input characters occurs in the input string. Well, in this case, 0. Agree? Doesn't occur anytime. And this one, just 1. Okay? And what about this one here? 0. Good. So now, okay, hopefully you get an idea, but let's see a longer string. Okay? And now, what about this? 2, right? Okay? No, 3. Sorry about that. Didn't see the A at the end. So 3. And then, etc. Okay, so now what we want to do is, given such input, 2 inputs here rather than 1 input, how do we really count the number of occurrences of the character in the string, which is like an array of characters recursively? How do we do that? Okay, okay, I'm going to switch to iPad. Anyone want to contribute your thoughts before I give you some hints? Anyone? I would say the way you divide into subproblems would be very similar to how we did it for reverse off. Would be very similar. Very similar. You want to think about how you can somehow solve some part of the string immediately. And then for the rest of the problem, we're going to delegate to recursive call. That's what we want to do. Okay? Anyone want to try before I give you hints? Anyone? Nobody? Oh, you want to try? Yeah.
I just want to say first check the length of the array.
You want to check the length of the array, sure, and then?
And then see if it's not, it doesn't have any element, just return the string, like just return 0.
But when you say you check the length of the array, that's about overall array, right? Are you going to really go over the array and see if the element is there? In that case, that's not recursion. The good thing about recursion is you don't really have to really go through the array. That's simply like an iteration, but we don't want any iteration here. Yep.
If it's empty, then it has 0 element.
Well, you're basically talking about base cases, right?
Yeah.
Okay, so if that's empty, we simply know always returns 0.
Okay, wait.
What about if the length is 1? What if the length is just 1? Then what do we have to check? Well, if the character is really the same as the 1, if it is equal, 1. Otherwise, 0, right? Okay, so these are the 2 base cases. What about recursive case? What if the string is very long? What should we do? Anyone? Give you a little bit visual hints. What you can do, let's say we got, when I say very long, let's say the length is more than 2, okay? A, B, C, A. Now, I'll give you visual hints. Versus, let's say that's red, and then I'll give you green. You can see the way I split the string is very similar to how I did it for the reverse off. So now, the way we call the way we split the problem to call recursion will be very similar. But the way you combine the result will be a little bit different because it's a different problem to solve. And you can definitely try to see from a small example, let's say over here, A versus D. We know that in the case of A, the number of recurrences will be 2. And number of occurrences for D would just be 0. Right? So these are 2 examples. But how do we do that? Okay, let me give you some further hints. I can simply just say, I will just take the first character. First of all, okay? The first character is A. When I know that, let's say for this problem over here, okay? A is simply equal to A. So I know that this counts as 1 occurrence. But for the rest of the string, which is the green part, I simply don't know. It's too complicated for me to solve. So what I would do is I'll delegate that to a recursion. So how do I do that? I'll simply say, why don't you just go ahead and calculate recursively? I'll say I'll say OCC for occurrences. And then I simply take out A because that has been handled already. And then occurrences of B, C, A, and then of A. So what does that mean? That means I'm going to see, first of all, if the first character is the same as the character I'm looking for. If that is, I will count as 1. And then I will also try to count recursively what's going to be the number of occurrences with the same character, but now in a substring by taking out the first character. Now in this case, what would that be? In this case, well, it's simply just substring. Well, eventually I should expect to get just 1 from here, right? So that means eventually I can get 1 plus 1, I'll get 2. Let me say that once more. What I will do is I will split the original string into 2 parts. The first part is simply the first character. Second part is basically the tail of the string, right, without the first part. And then I'll do the following. If the first character is simply equal to the original string I'm looking for, and then I'll count as 1. And then I will see whatever result it is for the second one, for the second part. And then combine the result together using addition. In this case, I get 2. Let's do another problem here. Let's say I'm talking about the second case over here. I'll split the problem in a similar way. Again, the first part will be just the first character. So I would say D, which is the character I'm looking for, equals A. I know that it's false in this case. That means I'll simply count it as 0. And plus whatever result it is, and now I will still get a substring over here that's strictly smaller, and then I will get B, C, and A, and then I will get D, in this case, the same character. So now, what do I expect to get from this particular recursion in this case? Well, just 0, right? Because D simply does not occur over there. So I'll get 0 plus 0, I'll get 0. Should we do one more? Just do one more. What if I want to find out the number of occurrences for, let's say C? How do I do that in this case? Well, split the problem in the same way. Again, the first character is A, get it? Equals, the character I'm looking for is C. This part here is simply false. I'll count this as 0. And then plus the number of occurrences, and then I would say BCA, which is the tail of the string, BCA. And then I will put this, the same character over here. So what do I expect to get from this? 1. That's what I expect to get. So I'll simply expect to get 1. So 0 plus 1 will give me 1. Are we okay with this? I'll do some more detailed tracing with you. But now this is really to get an idea, right? How you split the problem, and how you can expect the correct result from the recursion, and how to combine the result together. Yeah, you first? Yeah.
I was going to say, but if you were to do a tree, then you'd have to look at like the BCA and then do the same thing, right? Like,
yeah, exactly. But that's something we would get. You're talking about how we trace it, but I'll get there once I show you the code. Questions? Yeah.
So I don't really get why I'm comparing.
The first character. Yeah, because you always want to do something small first. And then, so that's why you can reduce the original problem into a smaller one, right? Because let's say this. You're given the string, let's say, you're given this string A, B, C, A. That's the original string, right? So if you simply don't do anything over here and simply just say, what's the occurrence of A, B, C, A? So in this case, you're not really reducing the problem for the recursion. So we'll go into the infinite recursion that we talked about last time, right? So that means you want to somehow reduce the problem into a smaller one. This is how we reduce it. We simply say, I can only check to see if the first one is already equal to the character I'm looking for. If it is, I'll just do it right away. It will just be 1. Otherwise, it will be 0. And then I will rely on the recursion to work on this particular strictly smaller problem and then do it. Okay? Yeah, again, we always make sure you satisfy 2 criteria for recursion. Number 1, you make sure you got base cases. And number 2, always when you try to make recursion on a strictly smaller input. How do you get a strictly smaller input? You do something in the current invocation of the method, and then you can reduce it. Okay? Yeah. Guys, any questions about this? I'll show you the code, and then let's trace it all together. Okay? Let's go to the code over there. I can just show you the code right away from here. Okay, number of occurrences, right? Over here. So what I would do is, again, we got input here. Let me just highlight. So this is the original input, just S. It's a string. Okay? And then over here, we got just simple base case. If the string is simply just empty, always return 0. That's a base case. Okay? And then otherwise, we got a recursive case over here. How do we get a recursive case? First of all, we get the head of the string, the first character. Like in this case, we get A. And then what we'll do is, we'll get a tail, which will be a substring by using the same method as before. That's how we get BCA. right? That's how we get it. And then once we get it, so now you can see that over here, this is what we'll do. We got two possible cases over there. We want to see if the head is equal to the character that we're looking for, right? C is over here, right? We want to see they're equal. If they are equal, you count as 1. Otherwise, you count as 0. Two cases. So now, once we have done this part, that means we can reduce the original problem to a strictly smaller one by simply considering what's going to be the number of occurrences of that particular character for this substring here. So the way we do it is simply just have two possible call to the same recursion, but now you can say tell, and then the same character. Right? Any questions before I try to trace the code together with you to have more understanding? Okay? Now, let's do it together. How do we trace it? Let's say, what I would do is, let's say this. Let me just try exactly this problem, A, B, C, A, right? Let's say we got occurrence, I'll say OCC, and then A, B, C, A. And then I want to count what's the occurrence of A. I just ignore the double quotes and single quote, just make it easier. This is the original problem we are trying to solve, okay? So what we will do is, first of all, we'll try to, let me just be more consistent. Let's say, take the first character here, and then we also say the red part is the reverse, so not reverse, the rest of the string, the tail, okay? So what we will do is, we're gonna say, there'll be two parts over here. We're first of all going to compare A and A over here. Since they are equal, it's going to count as 1, okay? Plus the occurrences of the rest of the string, the tail. So that will be B, C, and A. So this part is already done. We don't have to be suspended by that. So now we want to make sure this one is also completed before we can go, return. So now for this part over here, what we will do is, let me use this part here. So now let's say the first character is simply B here, and the second part is CA over here, okay? So what we will do is something like this. So we'll boil down into, so now, you know what, let me do it a little bit better. The method code we are trying to do is like this. The original, the substring will be BCA, and also we are checking to see how many times it will occur in, A will occur in that, okay? So now what we will do is, so now what should be the number that we put over here, right? Because we know that now the string we're talking about over here is BCA, and then the character is just the original character, which is A, okay? The same as before. Now, the first character is simply just B, right? Is B equal to A? No. So it will count as 0, okay? 0 plus the occurrences of, now these tail of the string will just be CA. So that'll be CA and then A. So also good? Okay, we're not done yet. So what we should do is, we should go on, okay? It seems to be out of space. Okay, like that. Okay, let's now go on. So now for this part here, it's CA. So how do we divide the problem? Well, what we do is, so we're gonna take the first character and then the rest, which is A. The first character is gonna be C, and compare with the character we're looking for, which is A. C is not equal to A. So what we would do is just say 0, because they are not equal, C and A. And then the rest of the string will just be A, right? So now we just say occurrences of A and then A. Okay? Are we reaching the base case right now? According to the code. Well, there's only base case, right? There's only one if branch. Yeah. So it's only a base case if there's an empty string, but it's not empty string just yet. So not yet, okay? So what we'll do is, again, what we'll do is take the first character. So what will be the tail in this case? If the first character is A. So what will be the remaining part of the string? Well, just empty, okay? Just take it in mind. Okay, now what we'll do is we're gonna compare the first character and this character we're looking for. Again, it's gonna be 1 plus, and now what we do is occurrences of empty string and then A. Okay, so now it seems like we are lucky enough to get to the base case. If you say occurrences of empty string, which will make s dot is empty, true, right? That means we're going to return 0. That means this part here is going to return 0. So what do we get? 0 plus 1 plus 0 plus 0 plus 1. So we get 2. Okay, that's how the thing will work, right? Any question about this for number of occurrences of? Yeah.
Where APIs do this, like Java,
What do you mean?
there are a number of occurrences.
Well, it's not relevant here. Of course, there are many problems there that simply defined already for you, but you should know how to solve that recursively, right?
Saying, do the APIs do it recursively? No, right?
I think that for this problem here, of course, to count the number of occurrences, you know how to do that iteratively in 1022. But here, the focus should not be the problem itself. It should be how you apply the general pattern for solving problems recursively to this. That's more important. Because in the exam, maybe we'll simply say, now for this problem here, number of occurrences, now you're required to solve it recursively, maybe, right? Okay. Any questions about this before I move on to a new problem? You okay, right? Okay. So now, let's now move on to something that's slightly more challenging. Okay? So far we are dealing with basically just single value, like a string. But you can think about string is like an array of characters. Let's now deal with just array. Let's see how we can. Of course, it can be also array list or linked list, pretty much like what you were given for lab number 6. Okay? So this will be relevant to your lab number 7. Okay. Okay. So now I want to talk about just how we can make recursive call on an array. Now, let's get something, I'll show you some general pattern over here, and then I will do examples. We've got 2 examples for you. Okay. We know that every time when you're trying to make a recursive call, you must make a call on a strictly smaller problem. So that means if the input is simply just an array, maybe an array of string or an array of objects, whatever it is, just an array. So when we try to make a recursive call, we must make sure the array that we are passing to the recursive call must be strictly smaller. Agree? That's the input size. Okay. Now, let's have a look at some general pattern over here, and then I'll show you in the tree trace. Okay? We're going to consider 2 different versions. Let's consider some very naive but easy to understand version, and then I'll show you what will be the standard way of doing such stuff more efficiently. Okay? That's kind of the pattern. Let's say, naively, every time when you want to make a recursive call on a strictly small array, intuitively, just create the array using a loop. So what do I mean? Let's say this. Let's say I have a method simply called n. Okay, just men. I am taking simply an integer array or string array, doesn't matter. Okay, an array A. Okay. Now let's say the base case is if the array is simply just empty. It's a base case. I do something immediately. If the array has the size 1, I do something immediately. So these are the typical base cases for array. Okay? The 2 basic are easy, straightforward. Now, what if I don't really satisfy the 2 base cases? That means the size of the array is larger than or equal to 2. So what should I do? What I should do is somehow I should really maybe, for example, one way to do it, I'll take the leftmost elements. And then I'll take the remaining part of the array and call that for the recursion. That's strictly smaller. I'll show it to you, and then I'll show you on the iPad. It could be that I simply have a subarray. Okay, I'm just creating a new array. I'm creating a new subproblem for me. I simply say integer array or string array, doesn't matter. I just call it subproblem. And you can see the size of the problem is strictly smaller. The original size of the problem is simply a.length, but it's a.length minus 1. Okay? And then what I would do is I'm just creating this particular subarray. So that means I ignore index 0. I'm just ignoring the first elements. And then starting from the second elements of index 1, I'm just fill it in. You have seen this kind of loop, right, already. What's the complexity over here, asymptotically? If the array size is n, is this a constant operation or linear operation? Linear, right? Because you can see that it depends on the size of the array. If the size of the array is 1,000,000, you're going to run this 1,000,000 times, right, for the iterations. Okay? But it's intuitive. That's why I say it's naive. After that, we'll simply say whatever the subproblem we have, we simply call the recursion. Okay, and you can see we're calling the method recursively on this particular subproblem. If you consider sub versus A over here, they're different, right? Okay. Again, let's have a look, and then we'll trace them together. So now I want you to focus on these two arrays over here. One is the original problem, which is A here, and also versus the sub over here. Okay? We agree that the problem over here, this is a strictly smaller problem. Strictly smaller than A, right? The original problem, that's what we know. So that satisfies the criteria for recursion. Okay? Any question about this first naive solution here? Okay? The problem is easy. We want to somehow recursively go through an array, any array of arbitrary size. And now, a very naive solution would be, every time you want to make the recursive call, simply starting from the second element, creating a brand new array, and recur on that particular subarray. Okay? You can see that it's not very efficient, right? Space-wise. Because every time when you make a recursive call, you have to create a new array, right? Okay? Let's see how we can trace this. Okay? Let's just go very smoothly, slowly. Case number 1. Let's say we got A1 over here, and it's simply an empty array. And then we want to consider calling M on A1. This one should be rather trivial, right? Because we are reaching the base case right away. So now this one here, we're just reaching the base case. Okay? This one is very trivial, no recursive call. Okay? What about this one over here? That's A2. Let's say we consider a string array, so that's easier for you to see the contents. Okay? It simply got the content just A over here. And then we want to consider how do we call N on A2, which considers single elements. It's also base case, right? Because you can see that A.length will be 1, so this one just length 1. So that will be also fine. Okay? So far, no new array is really created. No, so far it's okay. Now, here comes the tricky part. What about I got A3 here, and I got 4 strings inside. Okay? Can you imagine how many arrays are we going to create in total? How many arrays eventually do we have to create in this case? I heard 4. Okay, how about we just say 4 for now, but we'll see exactly. The original array doesn't count. Okay, let's see. Let's try to trace this particular one. Okay, what I will do is I'll start with, so we say N here. Let's just put it here. So A3 is pointing to an array of size 4. I'll put it like that. Okay, so we got A, B, C, and D. Okay, that's how we start with. And then we're trying to make a recursive, we're trying to call that N on A3. Okay, let's run it together. We know that A3.length would be 4. So that means we're not going to execute the base case, not here either, but we're going to go to the else part. And else part is going to create a subarray, right, starting from the second elements. So what we will do is, I'm going to use a different color here. So what we will do is, we're going to create another array called sub. And that is going to contain exactly from the second elements, right? So that will be B, C, and D. So that's what it will be done for this part here. So create this array here, and then, so let me just say that. In order to call M of A3, so what we will do is we'll call N on, and then we call M on sub. The sub is simply the new one we are creating. So now we'll say N on sub. Are we okay with this? What's really happening here is, when you started with the original problem A3 over here, which is an array of size 4, in order to make a recursive call, we have to reduce the problem size, right? Now in this case, what we're doing is we're creating a brand new array over here by running this loop over here. And then when we made the recursive call, we made the recursive call on sub. That's what we're doing. Okay? Now, how do we go on to that? Let's say now we got sub over here, so what should we do? Well, it's not a base case yet, right? Because now this now So now A will be replaced by the sub that we have. So now the size of the sub will be 3, which is none of the base cases over here, right? That means we have to again go to the recursive case. How do we deal with that? We have to create another subarray, right? So create another subarray starting from index 1. So that means we just create another sub. And then in this case, it's going to be C and D, right? Just subarray. And then after that, we're going to say N on sub, the green one. Okay? Now, are we reaching the base case yet in this case? Not really, right? Because the sub over here is of size 2, not yet. Okay, let's go a little bit further. So now what we will do is we'll go, let's say, for orange. And now if we try another one, what we will see is we're going to create another sub over here for the base case, for the recursive case. So now starting from index 1 to create a sub array. So that'll be sub pointing to just D. Okay, and then we'll say M on the sub. Now, this array here has size 1. So that means we're going to reach the base case over here and then do something about it. And we are done, right? So this is where the recursion will terminate. Okay? Of course, according to the size of the eventual array. But now you can see that over here, this is some extra array we have to create for the first recursive call. And this is the array that we have to create for the second one. And this is the array we have to create for the third one. If you think about how much time it will take, it would be, if you think about it, what will be the running time for this? Well, each individual one will just be linear, right? You can think about this one will be n minus 1, because B, C, and D is the size of the original array minus 1. And CD over here is the original size of the array minus 2. And then this is the original size of the array minus 3. So it's a decreasing element until you reach 1. So if you add them up together, we should be quite familiar with the series, right? Add them up together, you will get quadratic. If you add them up together over here, you will get n squared. Okay? So this is not really an acceptable solution over here. But I would say that's intuitive enough, which means every time when you're trying to make a recursion, I simply just use a loop to calculate a strictly smaller array and then pass that for recursion. But to really create a subarray, it takes linear time every time you try to make the recursion. So if you add them up together, it will be quadratic. So that is not acceptable. Okay? Question about this? Are we okay? All right. So what we should do is we should really try something that will achieve something similar to this, but make it much more effective, which means we want to somehow get rid of these two lines over here. We want to get rid of them. Okay? So what would be the way to do it? The intuition is when we are getting this particular array, you think about A, B, C, D. Every time when we are making a recursion, we are not really changing the array, right? We're only trying to see a certain part of the array. We're not really changing it. So that means there's really no point to really keep making new contents, whereas we don't really change them. There's no point. So what we can do is call by value. We simply pass the original array, but what we should do is, you can think about this particular recursion. If you think about B, C, and D, it's really the original array, but you only consider a certain range. You can think about this. So now we're moving towards the final solution. If you think about this particular sub, this is really the original array from index 1 to index 3, right? Index 1 to index 3. That's what I'm trying to do here. So if I can give you the original array and also telling you for this particular recursive call, you should really consider index 1 to index 3. Okay? Similarly, for the green one over here, it's basically considering from index 1, let me say it again. It will be from index 2 to index 3, right? C and D. So index 2 to index 3. And finally, this particular one will be the subarray of size 1. And in that one, that'll be from index 3 to index 3, just this index here. So now let's move on to the more efficient solution. And that's something you're supposed to do for any recursion on the array. Okay? Let's see. Questions for this? All right. Now, this is the pattern for recursion on array. Okay. Now, how do we deal with that? Okay. What we should do is, over here, let me just highlight the difference over here. So we still have this method here, just n, right? But now, not only that we're going to pass the array as before, we are also going to give two additional inputs. One is called from, the other is called to, two indices. You can think about for the very first recursion, we're going to pass 1 and 3. For the second recursion, we're going to pass 2 and 3. For the third recursion, we're going to pass 3 and 3. Basically, that's what we'll do, rather than creating separate arrays in each recursive call. So we are achieving really the same thing, but much more efficient implementation. Okay, but we'll trace it together. Okay, let's just go over that very quickly. Okay, if you try to see the correspondence, for example, this one might be easier to see. If the index are simply equal to each other, that should really consider as a base case, because if you see that over here, when, let me just show here, when 3 is simply equal to 3, that means we're considering just a single element of the array. It's a single array. So that's why it's one of the base case. Okay? There's another base case, which is not so obvious, but I'll do the tracing with you. Another base case would be when the from is actually strictly larger than 2. In this case, it will be also considered as another base case, which means an empty array. Okay? Empty range, basically. But we'll see cases. And now, let's look at how do we handle the recursive part. If you consider the else part over here versus the else part over here, the difference is in the previous version, that is inefficient. We have to run a loop to create a subarray. But in this case, we don't have to. All we have to do is we're going to make a recursive call. We're passing the same array by its value. And then the original problem is we're going to consider from to 2. But now it's going to be from plus 1 to 2. That's where the trick is. So somehow I'm claiming that this tells us to consider a strictly smaller problem. Okay? But to convince you, let's trace. Okay? So there's no need to create any new arrays when we are doing the recursion. All we do is we simply keep increasing the starting index to consider for the original array. Okay? Let's see. Again, let's consider 3 cases. Okay? So we got basically 2 base cases, and we got recursive case as well. Okay? Now, let's see how we can do that. Okay? So let's say we simply got A1 is the empty array. Okay? If A1 is the empty array, this one there's a typo here. I'll write it out again. It's going to be, we're calling the method m. We pass A1, and then from where to where. Okay? Always we want to go from the first index until the last index of the array. It's going to be always from index 0 until A1.length minus 1. That's always how when we make a call, like this way. Okay? And then similarly, so here we got A2 and also just one single element. We'll see. I'll just change this. This again is a typo. I'll say n, now calling A2, and then from 0 until A2.length minus 1. Okay, that's the second one. And then we got A3 here, which got 1, 2, 3, 4, 4 elements here. And then we'll consider, again, it should be n. We say A3, 0 until A3.length minus 1. Okay? So every time we're making a recursive call, simply say, given this array, either A1, A2, or A3. So this is what you should consider. Simply consider from the first index, which is 0, until the last index, which is array.length minus 1. Okay? The same for all the 3. But now we want to see exactly why the first 2 will be the base cases. Let's see why. Okay? The first one. Well, A1.length is, well, simply just empty array, right? So the A1.length would be 0. 0 minus 1, minus 1. That means we're really trying to call n on A1 and then 0 and then minus 1. So that means we got A1 here, and then we got 0 and we got minus 1. So this is a base case because you can see the from, which is 0, is strictly larger than the 2, which is -1. So this is a case where it's empty array, right? Okay. Now, what about a second base case? The second base case is A2. And now we just got one single element. So that means A2, the length over here is 1. Okay, and then 1 minus 1, the last index will be just 0. So that means we go from, so now it will be A2, we go from 0 to 0. It's also reaching one of the base cases, right? So now, so we don't really reach the if part, but now for the else if part, yes, we'll get there. Because 0 is equal to 0. So that means we will reach another base case. Okay? That's about the two base cases. Any question about it? Okay? You can see that in the two base cases, we also don't create any new arrays like the previous one. But now, we want to see that for the same array with size 4, how can we simply not create any sub-arrays that is strictly smaller, but we can still achieve the same stuff as before? Let's see. Okay? Let me, before I do the tracing, let me just give you a quick overview. Okay? Now we're going to consider this array here, A, B, C, D. Okay? Let me just tell you what's going to happen here. If you think about this is A3 that we are considering as the input. Okay? So we got A, B, C, D, indices 0, 1, 2, and 3. Okay? Thinking this way. Okay? Now, I'm going to use different color to tell you. When we first call this particular method over here, we say it's going to be from 0 until, you can see 0 here, until A3, the length, minus 1. So that'll be these two indices, right? Now, when we try to make the very first recursive call, that means we're going to increment to say from plus 1. So now from will increment from 0 to 1. And 2 stay the same. So that means for this first recursive call, this is what we'll get. We're basically specifying, for the second one, you'll go from 1 to 3. Right? It's a strictly smaller range that we're talking about. And then from there, we try to make another recursive call, in which case, we'll again do from plus 1. And then it'll be from 1 to 2, right? In that case, we'll just go again. So we'll go from 1 to 2, so that'll be 2 to 3. Okay? Eventually, we'll get to, just one more. Eventually, we get to 3 to 3. Okay? 3 to 3. Okay? It's a very quick overview. But let's see exactly how this will happen in the tree view. Okay? Any questions so far before I try to trace it? Okay? Okay, let's try. Okay, what I will do is I will just ignore, get rid of the color over here, and then let's do it again. So we got 0, 1, 2, 3. 0, 1, 2, and 3. And then meanwhile, I will get rid of the coloring over here, and then let's try to trace it all together. Okay, once you got this general pattern here, we can solve two problems related to this quite quickly. Okay, but it's really important to understand this. Okay, let's try that. Okay, let's try this particular one. Let's say A3 is simply A, B, C, D, and then we are trying to trace the following call. Okay, let's try this. So let's start with green. The original problem is n calling A3, which is referring to this array here. I want to go from 0 to 3. Okay? From 0 to 3. Okay, that's how I start making the call. Okay? So now, I start with this, and then I simply got A3 over here, and then the from will be 0, and the 2 will be 3. Okay, A length is 4. 4 minus 1 is 3, right? That's how I make the call, like this. Okay? Start with this, and we know that from is 0 and 2 is 3. It's neither of the two base cases, right? It's neither. So that means we have to go for the else part. For the else part, what do? We have to make a recursive call over here, and then the same array A, which means we don't create anything, to pass by value. Okay? And then this will be from plus 1. Currently, from is simply just 0. 0 plus 1 will give us 1. and 2 remains to be 3. So what we will get is something like this, okay? Let's use blue. So what we'll do is, from here, we'll get the same method over here, and then we also give a 3. So we're talking about just the same array. Don't create any new one. But now, rather than having 0, we're going to have 0 plus 1 over here. So we're going to get 1, and then 3. So now we're really talking about now, consider just this range over here, from 1 to 3, okay? Or you can think about from 1 to 3 over here. Okay, now, how do we handle this particular recursive call? Well, is it a base case? Not really. Okay, good. Let's try. Let me use red. So what we'll do is, so now we got 1 and 3. Let me use blue here, first of all. So we got 1 and 3. So that means the from will be 1, and the 2 will be 3. Okay, and also we still got a 3, the same reference. Okay, so now 1 and 3, we know that it's going to pass neither of the base cases over here. So now we still go to the else part over here. So now what we'll do is the same array, and now that will be from plus 1. So that will be 1 plus 1. Agree? So that will be 1 plus 1. I'll just write 2 here. And then it will still be 3. Right? So what we'll do is we're going to say make another call, and then a 3. So 1 plus 1 will be 2, and then 3. Conceptually, we are really considering from 2 to 3, basically these two elements, right? Without making a new one, okay? One more. How do we go on to the next one? So now to really handle this particular call, so we have to do, let's say 2 and 3 over here. And then we know that, again, it does not satisfy any base cases just yet. And then we're going to call the else part. And 2 plus 3 will be 3 and 3 over here. That means we're really calling A3 the same array, and then 3 and 3. Now, are we reaching the base case over here? Yes, we are. Because 3 and 3 over here is going to satisfy exactly this base case. And then we are done. Okay, and everything else will just return. Guys, are we okay with this? Okay, it's very abstract, I agree. But as long as you can see the change on the indices, that's my point. Okay, we haven't solved any concrete problem just yet. But the two problems we're going to deal with in just a moment relies on this particular pattern. Okay, let me recap the pattern very quickly, and then we'll solve problems. In order not to create any new arrays in the body of the code, which is very inefficient, what we will do is we have to introduce some extra inputs over here. Some from index and some to index. So that will specify which range of the array that you want to consider. So it's as if we are trying to create a new array. It's as if, but now we're not really creating it. Okay? So now, the very first time, we're saying that it's going to be from, for the very first time, we say it's going to be from 0 to 3. It's as if we're going to consider the original array like this. And for the second time, we're saying from 1 to 3. It's as if we're considering this strictly smaller array. And then the third time, we have from 2 to 3. It's as if we're considering this strictly smaller array again. And finally, we got the pink. So from 3 to 3, that means we're considering this. And that means we're reaching the base case. Okay? I would say this pattern over here applies to many of the simple problems on recursion on the array. Okay? Any questions before we see some concrete problems? You will see the pattern will just apply directly. But now the tracing will be much easier once you understand this pattern over here. Okay? Any questions before I move on to the problem? Okay. Let's move on to the problem. Okay, exactly what is said in the slides. Now, easy one. Let's say you give it an array of integers. How do I know if all the integers are strictly positive? Okay, let's see. Well, again, you're going to think about base cases. You're going to think about recursive cases. Let's just see some examples over here. What about empty array? Are all the numbers in the empty array positive? Well, should be true or false in the base case? True or false? Anyone? For you? Oh, no, think logically. Okay, this is, yes, go ahead. Ah. Yeah, for those of you who took 1022 with me, you should know this. Okay, maybe you forgot. Anyway, so let's see for the empty array. Logically speaking, okay, if you're given an empty array, how do you know if all the numbers are positive? Well, as long as you cannot find a witness number that is negative, that means all the numbers are positive.
So what was this witness violation?
As long as you cannot find any violation, that means the property should be true, basically. Okay? I just mentioned that very briefly. Okay? So all positive empty array will be true simply means you cannot find any negative number to prove that the property is false. So that means it should be true. That's logically speaking. Okay? I believe in 1019 or 1090, when you learn about predicate logic, they got something like this too. Okay? But I'll just stay away from that. So what about here? Well, if I got 1, 2, 3, 4, 5, all of them are positive, right? So that should be true. And similarly, how about this? Well, it's because I got at least one violation over there, so that should be false. Okay? So that's kind of the problem we're dealing with. Okay? So now, this can be applied to really solve this problem recursively. We can apply the pattern we just learned in the iPad. Okay? But let's see. I'm just basically now is the time to really link from this abstract pattern over here to solve concrete problems. Okay? We are basically going to do the following. We're going to see whatever input array it is. We're going to start with 0 and the array the length minus 1, and then keep recurring on the array by increasing the from index. Well, and we're going to get something very similar to the tree like here. Okay, that's what we're going to do. Okay, let's see how we can do that. This is the idea for all positive, right? So what I would do is, before I show you the code, and then also do tracing for you, but let's think about conceptually how to understand what the problem is. Let's say 1, 2, 3, 4, 5, okay? Let's say we are given an array like this. Let's say this is the input array that we are having. Okay, that's A over here. 1, 2, 3, 4, 5, okay? Now, I want to know if, I would say all P, all positive, okay? I want to know if all the elements in array A is positive. That's what I want to know. Okay? Conceptually, what I can do is, it's similar to counting the number of occurrences. Similar. Okay? I want to do something right away so that I can reduce the problem to a strictly smaller problem. Okay? What I can do is, again, I can say, let me just consider the very first elements in the array to see if that's positive or not. Okay? And then I can recur on the rest of the array. And for the rest of the array, I don't have to create a subarray. I don't have to. I just have to increase the from index. Okay? So what I would do is, I would simply say, in order to say all positive A, okay? All I have to do is to say whether the first element, which is A0, whether that is positive or not, which in this case, 1 is positive, so that will be true. And the rest of the array over here should be also positive, right? So I would say all positive, and then I should really conceptually, I should really pass 2, 3, 4, 5. 2, 3, 4, 5 over here. It's a strictly smaller array compared with originally. But now, how do I achieve this part? Okay? The answer is, we have to somehow to say, for the original array, it will be from index 0 to index 0, 1, 2, 3, 4. From index 0 to index 4. But now, when I try to call this recursion over here, it should be from index 1 to index 4. Rather, right? That's how we did it before to say from plus 1. Okay? Let's see the code. Any question about this? Just conceptually. Yeah. One page before?
The script. So like, since still I would like to know why don't we just combine the first case and second case?
You know what? I would say the first, second case, like an empty array and array of size 1. In general, you may want to distinguish between these two cases because in some occasion, these two cases may not return the same result. That's why I'm splitting them into two. You will see that later. Okay, but in some cases, if you think both cases should return the same thing, you can say if from larger than 2 or from equal to 2, I will return the same thing. Right? That's up to your particular problem. All right, let's see how we solve all positive. Okay, now one more thing to note, which is also something relevant to your lab number 7. Okay, you can see that over here. Let's just talk about what would be the signature for the method. If you think about all positive over here, this is the only input we have, right? Integer array A, right? This does not exactly match what we talk about, which will be some array and also the from and to index, okay? This is something very standard to do if you want to solve a problem recursively like this. What you have to do is to say, for me to solve it, I have to define just another method over here for helper. I call it helper method. They have a very standard name. Okay, I'll just put it here. It's called a recursive helper method. And the signature of the method should be now very familiar. We're getting an array A, and also we got from and we got to. Okay, the two indices, as we said before. But now, how do we solve the original problem? The original problem is simply of size a.length, so that means we simply call the recursive helper method here, and then with a, 0, and then a.length minus 1. That's what we'll do. Okay, so in order to solve this particular problem here, we have to define a recursive helper method, which is defined over here, where we got from and to. So the reason I have from and to is not to create new arrays in each recursive call, to save the time. Let's see how we can define the array. Now, everything is very standard. If from is strictly larger than 2, as we said before, this is one of the base cases that we talk about. That's the empty array. If it is simply empty array, we know that there's no violation for all positive. That means you should return true. If from is equal to 2, that means we're considering just one single element, right? Just one single. If only one single element, from and to are simply the same index, just check to see if the corresponding element is strictly positive. Okay? Otherwise, we got a recursive case. Now, what will be the recursive case? It's very similar to how we did it before for a number of occurrences. You want to see if the from part, just the first element basically, from to 2. Well, we'll trace it in just a moment. The from part is simply larger than 0, and also make a recursive call. You want to make sure when you make the recursive call, you're dealing with a strictly smaller problem. How do you ensure that? Well, you say from plus 1. So that means rather than considering from to 2, you're not considering from plus 1 to 2. You're considering one less elements. So it's a strictly smaller problem. Any question about the code here? You can see, just one moment. You can see that one lesson to learn when you study the recursion for exam. The reason that I spent so much time talking about the previous pattern abstractly is because there are so many problems for recursion on the array that you can just apply that pattern. As long as you can list the base cases where the array is simply of size 1, of size 0, and also recursively. Once you get a pattern down, you're not very far from the final solution. That's why. Okay, questions? You mean the a from greater than 0? Yeah, I see what you mean. Yeah, you mean over here, right? Yeah, the purpose is very similar to, let's say if you want to calculate the number of occurrences for a character in a string, you simply go to grab the first character, compare that with the target character to see if they're the same. If they're the same, you count as 1. If they're not the same, you count as 0. In this case, we are taking the very first number in the array. If it's positive, count as true. Otherwise, count as false. But let's trace them together, okay? Let's do two cases. Okay, let's say, I would say all P over here, all positive. Let's say we do an array of, let's say, make it easy. 1, 2, and 3. Okay, 1, 2, 3. We know that eventually it should return true, right? Okay. So let's say we just got this array over here, and then we want to, so let's say A is simply pointing to an array of size 3. 1, 2, and 3. And the indices we are talking about is simply from 0 to 2, right? 0, 1, and 2. Okay, let's consider this example here. Okay, so now we are considering all positive. Let me just put the array name over here so you can see the direct connection. Simply put A here. Okay, how do we trace this particular one so that we'll get true? Okay, let's say we start with the blue over here. So in order to really call this, it's like we're calling this all positive with an array over here. To do that, we have to call the helper method over here. You can see there are two different methods, right? And for the helper methods, not only that we're going to pass A, but also we have to give beginning index and also the last index, A.length minus 1. Okay? So now let's see this. So what I would get is, I want to say all positive to begin with, and then you know what? I will put it over here. So I want to get all positive over here, and then I get A. Okay, that's how I start with. Calling this particular method, just one arguments. And then in turn, I will call this particular recursive helper method with 0, A.length is 3, minus 1 will be 2, right? So what I will get is, this will be all positive helper. Notice it's an H over there, and then I will get A, and then 0, A.length, 3 minus 1, 2. That means I'm really considering, basically, from index 0 to index 2 to begin with. Okay? And now, if I try this one here, am I going to reach the base case? So 0 and 2. So that means the from over here is 0, and the 2 is 2. Okay? And the array is still A, right? No new array is being created. So now, am I reaching the base case over here? Not this one here, right? Because from is 0 and 2 is 2, right? It's not this case over here. And also from equals 2, also not there yet. What I would do is go to the else part over here, and then, now here comes to your question, let's see, over here. Conceptually, what we're doing is, we want to say, the first element, make sure it is positive, and also make sure the rest of the array is also, all the numbers there are positive. So how do we do that? So what we're to boil it down into two parts, basically two parts over here. So now, A from larger than 0, the from is simply 0. A0 larger than 0. And then we want to combine them with conjunction, right? Just ampersand, ampersand. And then all positive helper. Now we are making a recursive call, right? So now we're going to say all positive, and now we're going to have the same array A. Now, how do I pass the indices to make sure it's a strictly smaller problem I'm solving? Well, from is 0. I'm going to pass from plus 1. So that means 0 plus 1, 1 and 2. Okay, can you see that? Now, this part here is good. Is that true or false for this part? Well, it's true. A0 is simply just 1, so that will be true. Now, what about the remaining part, which would be from index 1 to index 2? Let me use a different color here. So that would be from index 1 to index 2. That means I'm considering this part of the array. Okay? Now, what that would do is, let's see. So now, I'm going to get to this particular call. So that means the from would be 1, and the 2 would be still 2. So 1 to 2. Okay? Am I reaching the base case? In this case? Well, from is 1, 2 is 2. No, not yet. Not this case. And also they are not equal either. So I'm still reaching this particular recursive case. So what I would get is, I'll say A from larger than 0. From is 1. So that means A1 larger than 0, and combined with conjunction over here. And then I'm going to make another recursive call. So what do I get? Well, if you try to make the recursive call, it's going to be all positive. Oh, there's one thing I forgot. It should be all positive helper. Okay, don't forget. It's a helper method we're calling. Okay, and also here it's all positive helper. And now what should I call over here? Well, the original array, which should just be A. And then from plus 1. In this case, from will just be 1. 1 plus 1, you get 2. 2. Okay, we're getting there. So now, is this a base case? Right, good. Thank you. So now let's see exactly. So let's say it is a pink, 2 to 2, okay? So that means we are considering 2 to 2, which is exactly the last elements. Okay, what we will get is, because from is exactly equal to 2, 2 and 2, so that means we're going to return simply a from larger than 0. So what this will get into is, okay, what this particular recursive call will get into is over here. A from larger than 0. So A at position 2 larger than 0. Okay, now let's return. What's the result for this? A2 larger than 0. A2 is over here, larger than 0. 3 larger than 0 will be true. And then, so that means this part over here has got a result, which is just true. And then what about this part over here? A1 larger than 0. A1 is over here, which is 2. 2 larger than 0 will give us true. And then you get true and true. Will give you true. Okay, hopefully you're comfortable with that. So that'd be true. And finally, you can see this part here is true. True and true will give you, again, true. That's why eventually this will just give you true. Are we okay with this? Okay. One moment. Let me see the time. We got 3 minutes, right? Okay, 3 minutes. Wow. I'm not going to see you guys anymore after 2 lectures. I want to see you more today. How about just 2 minutes? Okay. What I want to do is, that's the all positive. Let's do one more very quickly. This one can be done in a very similar way. Now, let's say we have an array of integers. How can you be sure the array is sorted? Let's say 1, 2, 3, 4, 5. It is sorted. If you got 1, 2, 3, 4, minus 2, it is not sorted, right? How do you solve this recursively? Okay? I just want to spend about 2 minutes to talk about how it works conceptually, and then I'll trace it next time. But let's think about how we can do that. For example, if you got it sorted, now it's sorted on empty array. Should it be true or false? True. Why would that be true? Aha, you cannot find a violation, right? Very good. Keep that in mind. This might appear in the exam. Keep that in mind. Now, it's sorted 1, 2, 2, 3, 4. Wow, true, right? As long as it's not decreasing, then that will be sorted. Okay, and then we got 1, 2, 2, 1, 3. False. Very good. Let's talk about how to solve it abstractly, and then we are done. Okay, let's now have a new page. Now, let's say this. If I give you an array that looks like this, okay? Let's talk about 2 examples. Let's say 1, 3, 5, 7, 9, and 11. I'm asking you, is this array sorted or not? We know that eventually we should really get true, right? But now, how do I solve that recursively? I'll give you a little bit hints. You should split the array in the same way. You consider the first elements there, or the first 2 elements, and then you consider the rest of the array. I'll give you a little bit hints over here. What you can do is think about the first elements, and then think about the rest of the array. Okay? Now, anybody want to try, and then we are done? Anybody? Anybody want to try? Well, if I can get the first elements 1, right? Would that be just useful to consider just 1? Somehow I want to know if 1 is less than or equal to its neighbor, right?
Yeah.
Agree? So it's not that useful. Okay? We're getting somewhere. So, guys, please stay calm. Yeah.
So we need to sort this, right?
No, we don't need to sort it. We want to check to see if that's sorted or not.
Firstly, we grab every first number and compare it with every number behind it.
That's horribly
No, that's a for loop. You don't want to do that. We want to solve that recursively. When we solve the problem recursively, I don't want to see any loop. Okay? So now let's say this. If I say, I want to say, let's say I define a method. Let's talk about this and then quickly. Just give me 1 minute. If I say is sorted over here, let's say this is A. I want to say A from index 0 until index 0, 1, 2, 3, 4, 5. Okay? How do I define this recursively? Okay? I can simply do the following. When I'm trying to consider from 0 to 5, all I need to do is like this. A, 0, and less than or equal to A, and then here, 0 plus 1. So I'm talking about a 0 over here. Okay, 0 here, 0. Just consider 2 elements at a time. And then this will be one result I can do right away. Consider the current elements and its neighbor. Now, how do I run recursively? That means I should really say is sorted over here. Now, I can pass the original array, but what should I get over here? And what should I put over here?
Plus 1, 5.
Plus 1, right?
Plus 1, 5.
Plus 1 and 5, yeah. That means whatever 0 I get, I want to say what I just started with, I am only considering these two. What I should get is not only that these two should be sorted, but also the array that's over here should be sorted as well. So starting from 0 plus 1, the 0 over here, and then go until the end. I want to see if this part of the array is also sorted. If I were you, I would try to go over this example before Wednesday, before we talk about more tricky example. Okay, I'll see you on Wednesday.